All right, so on this page, we're going to talk about how to find the derivative of an absolute value. So this is our formula here. So we take the inside of our absolute value, that becomes our numerator. The absolute value doesn't change, and that becomes our denominator. And then we multiply it by the derivative of the inside. So let's do that with example 3. So the inside becomes our numerator, 3x minus 5. The absolute value becomes our denominator, so the absolute value of 3x minus 5. And then we multiply it by the derivative of the inside. What's the derivative of 3x minus 5? 3. Perfect. So this would be 3 times 3x minus 5 over 3x minus 5, the absolute value of 3x minus 5. This would be our derivative. How would we find our critical numbers from here? So our critical numbers, we can set it equal to 0. And how else do we find critical numbers? We'd set it to does not exist or undefined. We'd find what values give us undefined. So here when we have a fraction, you can either set your numerator equal to 0 and solve. Well, not either, but you'd want to do both. In this case, it gives us the same value. When we set our denominator equal to 0, this is what gives us the undefined, because it'd give us 0 in the denominator. How would we solve when we have absolute value bars there? How do we get rid of them? Typically, we'd make two equations, make a positive one and a negative one, but here since it's equal to 0, you can just get rid of them because we wouldn't have a positive 0 and a negative 0. So it would just be like solving 3x minus 5 equals 0. So our critical number would be 5 over 3. We would do the same thing with the top, set it equal to 0, and find our critical number there. It ends up being the same thing here. It's not always going to be the same thing, though. We'll find that it's different in example 4. It's technically, like, we would set the denominator to find, like, the domain or find what value makes this undefined. We'd set the denominator not equal to 0, but here we're just looking for the value. Like, what value of x makes our denominator 0? So it kind of doesn't really matter because we're just listing the critical number. We're not saying like x cannot equal 5/3. It can't equal 5/3 because we can't have 0 in the denominator, but we're just listing our critical numbers. Let's do example 4. So first let's find our derivative. So our derivative, we write the inside up top. So x squared minus 9. The absolute value goes to the bottom. So absolute value of x squared minus 9. And then we multiply that times the derivative of the inside. What's the derivative of x squared minus 9? 2x, perfect. So that gets multiplied to the top. So to write this a little bit better, we could say 2x times x squared minus 9 over the absolute value of x squared minus 9. So to find our critical numbers, we would set the numerator equal to 0 and then our denominator equal to 0 to find where it's undefined. So our critical numbers come from where our derivative equals 0 and where it's undefined. So we have to set the denominator equal to 0 to find where it would be undefined. So we can solve our denominator first. We get x squared equals 9. Take the square root. What does x equal? Positive and negative 3, perfect. In our numerator, we could set both pieces equal to 0, so 2x equals 0, and x squared minus 9 equals 0. We already solved this one. It's the same as what we just got in the bottom. And the other one, 2x equals 0, x would equal 0. So we'd add that to our list of critical numbers. So here we have 3 critical numbers here. So we're going to find the extrema of the given function on the interval from -2 to 2. So first we want to find our derivative. So we take the inside, that goes up top, 1 minus x squared, over the absolute value, so the absolute value of 1 minus x squared, times the derivative of the inside. What's the derivative of 1 minus x squared? -2x, awesome. So this would be -2x times 1 minus x squared over the absolute value of 1 minus x squared. How would we find our critical numbers? Equal the bottom to 0 and the top to 0. So on the bottom, we'd get 1 equals x squared. Take the square root, so what does x equal? Positive and -1, perfect. On the top, the 1 minus x squared would give us the same values, positive and -1. So we would say -2x equals 0. So what would x equal? 0, awesome. So we've got 3 critical numbers here. -1, 0, and +1. So let's do what we did yesterday. Let's make our chart. Put the x values on top, our y values on the bottom. I'm listing on the chart my critical numbers and my endpoints, because critical numbers and endpoints could be extrema. So I'll list it in order. We have -2, -1, 0, 1, and 2. Now when we plug this in, remember you're plugging it into the original function. So here I have the absolute value of 1 minus -2 squared. -2 squared would be 4. 1 minus 4 would be -3. And what's the absolute value of -3? +3. Perfect. Let's plug in -1. So this would be 1 minus -1 squared, the absolute value. -1 squared would be +1. So 1 minus 1 would be 0. And the absolute value of 0 is 0. When we plug in 0, we have 1 minus 0 squared, which would just be the absolute value of 1. So that's 1. We plug in 1, we get the absolute value of 1 minus 1 squared. So 1 minus 1 would be 0, and the absolute value of 0 is 0. And then the absolute value of 1 minus 2 squared. So the absolute value of 1 minus 4 would be the absolute value of -3. What's the absolute value of -3? 3. So what are our smallest y values here? 0. Awesome. We do have 2 y values that are 0, so we have 2 minimums. So it is possible that you can have more than 1 maximum or more than 1 minimum. So our minimum points would be -1, 0, and 1, 0. I think that there's some on the WebAssign that might end up giving you 2 numbers. It says to list the smallest x value first, so you just put the -1, 0 as your first minimum. What's our largest y value? 3. Well, we've got 2 of them, so we have 2 maximums. So our maximums would be -2, 3. And 2, 3. Awesome. We want to find the derivative to help us with our critical numbers. So step 1, we want to find our derivative. What's the derivative of 2x? 2. What's the derivative of -3x to the 2/3 power? What's -3 times 2/3? -2, so -2 x to the When we subtract 1, we'd subtract 3 over 3. So this would be x to the power of negative 1 over 3. Or if you want to, you can write it as 2 minus 2 over x to the 1/3 power. Or you can change your exponent to be a radical if you wanted to instead. What's step 2? Awesome. Step 2, we want to set this equal to 0 or find where it's undefined. So let's set it equal to 0 first and solve. So when we solve here, I need to subtract 2 on both sides. So negative 2 over x to the 1/3 power equals negative 2. What would we do next to solve? We could. Yeah, that would work. I would just get rid of our fraction first. So we could just cross multiply. So we have negative 2 is equal to negative 2 x to the 1/3. But then when we divide by negative 2, that goes away. So it would be 1 equals x to the 1/3 power. What would we do next? How do we get rid of the 1/3 power? We can cube both sides, so it'll cancel out. So we have x is equal to, what's 1 to the 3rd power? 1. So 1 would be one of our critical numbers. We also have to find where this is undefined, which I kind of skipped this in the last question, but when we had a quadratic function, it's not undefined. But if we have a fraction where we have x on the bottom, it is possible that it can be undefined. So let's figure out where 2 minus 2 over x to the 1/3 power is undefined. What can I not have in the denominator of a fraction? 0. So we want to figure out what x value makes our denominator 0. So all we need to do is set our denominator equal to 0. The rest of the question does not matter. X to the 1/3 power equals 0. What would I do to solve for x? We can cube both sides so it cancels. What's 0 to the 3rd power? 0. So x equals 0 is another one of our critical numbers. So we've got 2 critical numbers here. So I'm going to make a table just like I did in the last one. So I'm going to put my x values on top, my y values on the bottom. Our possible places where we can have extrema are going to be our endpoints and our critical numbers. So just to write it in order, we've got -1, 0, +1, and 3. So we want to find f of -1. So we're going to take -1 and plug it into our function. So 2 times -1 minus 3 times -1 to the 2/3 power. 2 times -1 would be -2. -1 to the 2/3 power is like saying the cubed root of -1 squared. What's the cubed root of -1? And what's -1 squared? +1. So +1 times -3 would be -3. -2 minus 3 would be -5. Now let's plug in 0. So we want to find f of 0. 2 times 0 minus 3 times 0 to the 2/3 power. This would be 0 minus 0, which is 0. Next, let's find f of 1. So 2 times 1 minus 3 times 1 to the 2/3 power. So 2. What's 1 to the 2/3 power? 1. So 1 times negative 3 would be negative 3. 2 minus 3 would be negative 1. Next, let's find f of 3. So 2 times 3 minus 3 times 3 to the 2/3 power. This, we can put it in the calculator to find our value. When you put it in the calculator, you'll get negative 0.24. So looking at our y values now, what is our smallest y value that we have? Negative 5. So at the point negative 1, negative 5, we have our minimum. What's the largest y value that we have? 0. So at the point 0, 0, we have our absolute maximum.